Hey friends, welcome to kodEdge. In this session, we will see how to monitor Kubernetes and microservices deployed into the Kubernetes using Prometheus. And we will also visualize these metrics using Grafana dashboards. So let's get started. These are the topics we are going to cover in this video. So first, we will deploy Prometheus and Grafana into the Kubernetes cluster. Then we will monitor and visualize these metrics related to Kubernetes using Grafana dashboard. After that, we will create a simple microservice in Spring Boot and deploy it into the Kubernetes cluster. Then we will monitor and visualize our application metrics in the Grafana. So I have already created a video on monitoring microservice using Prometheus, in which I have already explained the basic of Prometheus, like Prometheus architecture. Then I have also demonstrated to create different types of metrics in that video. So I will attach its link in the video description. So if you want to understand the basic of it, please watch that video. So these are the prerequisites required for our hands-on. So you should have a Docker install on your machine to Dockerize our Spring Boot application. Then Minikube is required to create a Kubernetes cluster. Then next is a Helm, which is required to install the Helm chart. Next is a kubectl, which is required for the Kubernetes commands. And last is your favorite IDE and the JDK. So this is the Helm chart we are going to install in our Kubernetes cluster for deploying the Prometheus and the Grafana. So Helm chart name is a kube-prometheus-stack. So when we deploy this chart, it is going to deploy multiple components into the Kubernetes cluster for the Prometheus and the Grafana. And it is important to understand what is the use of all these components. So these are all the components get deployed when you install this Helm chart. So first section you can see these are the number of pods get deployed into the Kubernetes. So let's understand usage of all these pods. So first one is a alert manager. So what is the use of alert manager? So it manages and handles the alerts sent by the Prometheus, and it will forward that alerts to the appropriate receivers or notification channels like Slack or the email services. Next pod is for the Grafana. So this is a third-party service which is not part of a Prometheus, but it get installed with the help of this Helm chart. So what is the use of Grafana? So Grafana is used for the visualization of your metrics that is getting pulled from your application or the Kubernetes cluster, and you can create dashboard in the Grafana. Next pod is a Prometheus operator. So it uses custom resource definitions to define the Prometheus instances, service monitors, and other resources. So basically it manages the lifecycle of Prometheus instances and other monitoring resources. And we are going to see this CRDs and the service monitor in a moment. So next component is kube-state metrics. So basically this listen to the Kubernetes API servers and generate the metrics about the state of Kubernetes objects such as pods, node, and the deployment. So next is a Prometheus server. So this is a main component of the Prometheus. So it collects the metrics from the monitoring targets like your application, then store this metrics into the time series database. And last pod is for the node exporter. So what is the use of node exporter? So node exporter collects the various system level metrics from a node, which includes metrics like CPU usage, memory usage, disk usage, and the network statistics. Then it exposes these metrics in the format that Prometheus can scrap, and these metrics are useful to track the health and the performance of your node in the cluster. Then these are the number of services get deployed into the Kubernetes cluster, which basically useful to access these pods. Next is a daemon set. So let's understand what is a daemon set first. So in the Kubernetes cluster, daemon set ensures that copy of specific pod run on every node in the cluster. So this Prometheus node exporter daemon set is responsible for running the node exporter on every node in the Kubernetes cluster. Then this node exporter exposes the machine level metrics in the format that Prometheus can scrap. Okay. Next is the deployments, replica set, and the stateful set. And these are the custom resource definition, which is also called as CRDs, get deployed into the Kubernetes cluster for the Prometheus. And out of this, all the CRD, this one is important for us. So we are going to see this CRD when we are going to deploy our Spring Boot application into the Kubernetes cluster. So we will get back on this CRD later on. Now next what we will do, we will deploy Prometheus and Grafana into the Kubernetes cluster. So we are using kube-prometheus-stack. So let's search for that into the Google and let's open this GitHub link. And here you can find the all information related to this Helm chat. Okay, and this is going to install this kube-prometheus. These are the commands we are going to use for deploying the Prometheus and the Grafana. So let's copy this command and let's open the terminal. So before installing this command, let's start our minikube. So command will be minikube start -- driver equal to docker. Okay, so our minikube is started. So let's copy this command and let's run that command into the terminal. Okay, now let's run the next command to install the Helm chart. So let's copy this command. So command is helm install, then your release name. Okay, then this is the actual Helm chart. So let me open the terminal. So helm install, then release name. So release name I am giving as a Prometheus and the actual Helm chart name. Okay, so our Helm chart is installed. If you want to see, let's run the command helm ls. Okay, so this is the chart that we have installed now. So let me clear the window now and let's see the components that get deployed. So command will be kubectl get all, and these are the components get deployed, which I already explained in the introduction section. So let's wait for some time till all the components get deployed fully into the Kubernetes cluster. Okay, so all the components are active now. You can see status is running. Now next what we will do, we are going to access this Prometheus WebUI and the Grafana into the browser. So these are the services that get deployed with this chart. So let me clear this window and we will run one command, that is kubectl get services. Okay, so this is the service for the Grafana and this is the service for the Prometheus. So what we will do, so these are all the cluster IP services and these are all the internal services into the Kubernetes and which are not accessible outside this Kubernetes cluster. So for that purpose, we are going to use port forwarding command. So let's first access the Prometheus. So command will be kubectl port -forward, then service / and your service name. So service name is this one. On which port we need to forward, copy this port number from here. Okay, and let's run this command. Okay, so it is forwarding the traffic on this port. Now let's go back into the browser and let's run the URL, that is localhost :9090. Okay, so this is our Prometheus web UI. Now if you go into the status, click on this service discovery and you can see it is scraping the metrics for the Kubernetes. Okay, so you can see this is a service name for the alert manager, then the API server, then next is a Prometheus itself. Okay, and if you go here in the targets and if you expand this, these are the URL on which metrics getting exposed from the Kubernetes. Okay, now next what we will do, we will open the Grafana dashboard into the browser. So let's open the new terminal. Okay, so let me clear it and we are going to run the same command for the port forwarding. So service for the Grafana will be this one. So command will be kubectl port -forward, then your service name, and which port we need to forward the traffic. You can see for the Prometheus port is 80. So let's give the port number. So I'm getting error as a permission denied. So let's run this command with the sudo. So let me copy this command again and let's run this command with the sudo user. Okay, so it is forwarding the traffic on the port 3000. Okay, So let's run this URL in the browser, localhost :80. So we will require password to log in into the Grafana. So how to find the password? So let's open the new terminal again and let's do kubectl get secrets. And secret for the Grafana will be Prometheus Grafana. So let's run command kubectl get secret and your secret name, then -o and YAML. So this is the configuration for your Prometheus secret. And here you can see the name of your secret. So these are the username password details for your Grafana. So this is the username and this is the password. So you will require to decode this password and username using base64 format. So for that, let me run the new command. So command will be, okay, so let me explain this command. So what I'm doing here, I'm getting a secret. I'm using the default namespace. Then this is our secret name. And then I am finding the admin password from that configuration. And then I am decoding that password using base64 format. Okay, so let's execute this command and this will return the password for our Grafana. So let me copy this. Let's go back into the browser. So username will be admin and password will be which we copied from the terminal. Okay, so we are into the Grafana. Now if you go here in the connections, let's click on the data source. So here you can find the default connection for the Prometheus. So it is automatically created the connection for our Prometheus server. So this is our Prometheus server URL. Now we will see the dashboard for our Kubernetes cluster. So click on this menu icon here and let's click on this dashboards. So these are the dashboard automatically provided by that helm chart. So if you click on this Prometheus overview, okay, so this will return the metrics for the Prometheus server that is deployed into the Kubernetes cluster. Now, if you want to see the metrics related to the node itself, click on this node exporter. So this is the metrics related to the node. So this is the IP address of the node. Okay, so let me open the terminal again. Let's run command minikube IP. Okay, so this is the IP address of our node. And this is the same IP address you can see here as well. And these are the metrics coming from our node. And you can also import that custom dashboard using this import option here. Now next what we will do, we will create a simple Spring Boot service and we will deploy it into the Kubernetes cluster. So I am using a Spring initializer for creating a Spring Boot application. So the application name will be Spring Monitoring Kube. I am giving the same name in the artifact. So build system I am using as a Gradle one. JDK version I am using 17 and let's add the dependency. So first dependency will be for the REST controller. So dependency will be Spring Web. Next dependency, as we are going to expose the metrics from our application, we will require dependency for the actuator. And the last dependency for the Prometheus. So this will add dependency for the micrometer. And let's click on the generate. So let me open the project into the IntelliJ. So let's go into the build.gradle file and let's remove this version. So we are not going to use versioning for our jar. Okay. Next, what we will do, we will add the properties for our actuator. Let's go into the resources and let's rename this file to the application.yaml file. And let me copy the configuration. Okay, so let me explain this configuration. So this is a server port on which we are exposing our application. Then this configuration for defining our application name and which is optional. Okay, so this configuration I am using here in this application tag. Okay, so if you not define this configuration, you can directly specify the name of your application. Next, I am defining the number of endpoints that I am going to expose from our application. So what does this exposure and the include configuration will do? This exposure section will define which actuator endpoints we want to expose from our application. So this health endpoint will expose the metrics related to our application health. And this Prometheus endpoint will expose the metrics in the format which is required by the Prometheus server. And next we are defining the name for our application. Now next configuration I'm going to add for the Docker file to Dockerize our application. So let's add the new file. File name will be Docker file. So let me copy the configuration. Okay, so these are the configuration for Dockerizing our application. So what I'm doing here, I am using parent image as a OpenJDK. Then I am exposing our application on port 8080. Then I am copying the library name, that is our jar name, into the Docker. And this is our command to run our application. So our jar is going to create into this libs folder, into build folder. Okay. So next we will add the sample controller in our application. So let me create a new class. Class name will be test controller. And this will be our REST controller. And let me add one sample endpoint here. So it will be of the type get. I am giving path as a data. And let me return string from this endpoint. And let's return some message from Kubernetes or K8. Okay, so this is a simple endpoint which will return the string message from our microservice. Now let me quickly test this endpoint. So let's go into the main class and run this main class. Okay, so server is ready. And let's execute that endpoint. URL will be localhost 8080/data. Okay, so our application is working. Now next what we will do, we will add the Kubernetes configuration in this application to deploy it into the Kubernetes cluster. So let me open the terminal. So let's cd into our project directory. Okay, so this is our project directory. So I'm going to use Helm chart for creating the Kubernetes configuration for our application. So command will be helm create and your directory name in which you want to create the Kubernetes configuration. Okay, so it has created the YT chart directory. So let me go into the IntelliJ and you can see these are the configuration created for the Kubernetes. So this will provide us ready-made configuration for deploying our application, and we need to change only certain configuration. So let's go into the values.yaml file. So here we will first change our image name. So our image name will be, let's go into the Docker file and copy this name. So we are going to give same name that our application name as a image name. And let's copy here. Tag will be latest. And next go into the deployments.yaml file. And let's comment this liveness prob and the readiness prob. So we are not going to use this liveness prob and the readiness prob. Next, what we will do, change our service type to the node port, and port will be 8080. And here we are going to add few more tags, that will be service label, which will require to give label to our service. So I am giving as a service spring-svc. And next I am giving as a job name, and job name will be spring microservice -job. Okay, so I will explain in a moment why this configuration is required. Now next let's use this configuration in our service. So let me open the service.yaml file, and here let me copy the code for it. Okay, so what I'm doing here, I'm using the service label and the job name from the service section from the values.yaml file. Okay, so if you go into the values.yaml file, first go into the services, that is this tag, and into the service tag get value from the service label, that is this service label. Same for the job name as well. Okay, that's it. We are not required to do any change apart from this to get it deployed into the Kubernetes. So here is a question: how Prometheus server will discover our Spring Boot microservice, right? And for that purpose, it will require to add new configuration, and that configuration name is service monitor. So this is a configuration for the service monitor. So you can see API version is related to the monitoring, and kind is a service monitor. So this label is very important. Our Prometheus server will discover our service monitor service based on this label. And I will explain this label in a moment when we see the CRDs. Next is a job label for our application. And these are the Prometheus grep configuration. So here I am first defining the interval. Prometheus will scrap the matrix after every 5 seconds. Next is a path. So our application will expose the matrix on this path. And next is a port, that is a port name. This is a namespace selector. Here you can define the namespace in which your application is deployed. So here I am selecting as a true for any. Next is a selector in which you define the name of your application service. So this is the label that you define into the application service. And these are the CRDs. Initially I told that we need to see this CRD later on, right? So in this CRDs, this one is the important CRD. And this CRD contains this configuration that is related to the service monitoring selector. So let me open the terminal. Here we will run one command, kubectl get CRDs. And this is the CRD that we need to see. Okay. So just run command kubectl get your CRD name -o YAML. And in this CRD, search for the service monitor. And here you can see that label configuration. Okay, so whenever you are going to create the service monitor configuration, first see the label that is configured in your CRD, right? And this same label you need to define into the service monitor, and this label we need to give into the service monitor configuration. Now understand how we are going to attach our application service to this service monitor. So this is our application service, and in the service monitor it contains the section called selector, and in the selector you need to give same labels that you have given into your application service. And by doing this, our application service will get attached with the service monitor. Next section is for the port. So you need to give same name that you have given into your application service for your port. So here I have given name as HTTP. So same name I have given into the service monitor, that will be HTTP. So this is how you can refer the job. And next I am giving the same name that I have defined into the label section of our application service into service monitor job label section. And you can give any name to this section. Okay, so it is not mandatory to give name as a job only. You can give any custom name here. And this spring-microservice-job, this label will appear into the Prometheus metric section. So let's define this configuration into our application. So this was the configuration for our application service, right? And now you understood why I have given the job name into the service label section, right? So job name that I have given, that is spring-microservice-job. Okay, now next configuration we will add for the service monitor. So let's create a new file here to the template section. File name will be service-monitor.yaml. So you can give any name to your file. Okay, so this is the configuration for the service monitor, and these are the selector. So I am giving the same label name that I defined here in the selector section. Now what we will do, we will deploy this application in the Kubernetes cluster. So let's open the terminal. So let's first build our project. Command will be -w clean build Okay, so our build is ready. Now what we will do, before deploying or creating a Docker image, let's run this command. So this is a command useful for the pulling our Docker image. So normally what happens, if you don't execute this command, our minikube will try to pull the image from the Docker hub. But we are creating a Docker image on our local system for our application, and we want to pull the image from our local system, right? For that purpose, this command is important. And let's run command to create a Docker image. So command will be docker build -t. So name I am giving as a application name that we have given here. And at the end, I add the dot. So it will take some time to pull the images. Okay, so our image is created. So let me clear it. So next command we will run for the installing our Kubernetes configuration into Kubernetes cluster. So command will be helm install, then your chart name. So chart name I am giving as a my chart, and the configuration folder. So in this folder we have created the Kubernetes configuration. So let's execute this command. Okay, so our application is deployed into the Kubernetes. So if you want to see the charts, let's run the helm ls command. So these are the chart we have deployed into the Kubernetes cluster. So let me clear it, and let's run the command kubectl get all. So you can see this is our application pod. So it is running. Then this is our application service, right? So let's copy this name, and we will use the same command for the port forwarding. So command will be kubectl port-forward, then our service name, and we will forward traffic on port 8080. Okay, so let me open the browser now, and let's execute our API. Okay, so we are getting response from our application, right? And next we will also see the metrics exposed from our application. So let me open the IntelliJ, and let me go into the service monitor, and let's copy this URL and copy that URL here. And you can see these are the metrics exposed from our application. So let's go into the Prometheus WebUI, just refresh this and click on this service discovery. And you can see it has discovered our Spring Boot microservice monitor service, right? Then if you go into the targets, let me collapse all. And here you can see our applications. You can see it is getting metrics from this URL, right? Now, if you want to see the metrics related to our application, click on this graph button, click on this metrics explorer options, and here you can see the metrics that is exposed from our application as well as from the Kubernetes. So let's search for the HTTP. Let's select this metrics and click on the execute. Okay, so these are the metrics exposed from our application. You can see the job label that we have given into the service monitor configuration, right? And this is the metrics name, and this is the value for the particular metrics. If you click on this graph, you can see the graph as well. Okay, now what we will do, we will create a dashboard for this application. Let me search the dashboard for it. So let's search the Grafana dashboard. Let's go into this Grafana labs link, and here search for the Spring, and I am selecting this dashboard. Copy this dashboard ID. Let's go into the Grafana. Let me refresh this page and click on this import option here. Copy your dashboard ID, click on the load, and select your default data source, that is Prometheus. Click on the import, and here you can see the metrics related to your application, that is our microservice, right? And this is the same way you can import a dashboard for the Kubernetes as well. So if you go back here and if you search for the Kubernetes, you can find the dashboard for the Kubernetes as well, and you can import the dashboard in the same way. Okay, so this is how we have successfully deployed the Prometheus, Grafana, and the custom microservice into the Kubernetes cluster. So for that, what we did first? So first we deployed the Prometheus and Grafana using the Helm chart, which we can get from this GitHub repository, right? And if you go here, if you click on this kube-prometheus-stack, so it will open the actual kube-prometheus Git repository. And here, these are the section it included into the deployments. And if you click on this Prometheus operator, and if you go here into the getting started document of the Prometheus operator, here you can find the detail related to the service monitor, right? So what we did first, we deployed the Prometheus and the Grafana into the Kubernetes cluster. Then we created our Spring Boot application. In the Spring Boot application, we have created the service monitor configuration. And in the service monitor, we defined this label, and we got this label from the CID, right? Then we define the job label. Then we define this scraping configuration. Then we define our matching label from our application service. Then we deployed this configuration into the Kubernetes, and based on this label, our Prometheus server discover our application, right? So if you go into the Prometheus, if you go into the service discovery, and here you can see this application, right? And if you click on this graph, and if you want to search based on the job, so let's write the job equals, and our job name was Spring. This was our job name that we have given to our application. Let's execute. Okay, so this will return all the metrics related to this job. Okay, so that's it for this lecture. Thanks for watching the video.